So today we are going to do electromagnetism, chapter 10, ICSE class 10. So first it Oersted experiment, very simple. Oersted, when he kept a compass in a magnetic field or near the conductor, he found the deflection in the direction of compass. When no current was passing, the compass needle was slanted the wire in direction resting to north south, and when the current is passed from A to B, it deflected towards the west. It deflected towards the west. And when the current is passed from B to A, it was deflected towards the east. It was deflected towards the east. And simply by changing the polarity of the wire, we can change direction of its deviation. Next is magnetic field. So we know that if we put a wire and cardboard beside it and the iron fillings over it, we will see that the iron fillings arrange them in concentric circle. This shows that the magnetic fields are in the form of concentric circles. See, if we increase the current in the wire, these magnetic fields will become denser. The next is right hand thumb rule. What is right hand thumb rule? We use it to determine the direction of current in a conductor or the direction of magnetic field. So if I assume that this is the current is flowing towards upwards, towards up, so I will keep my thumb towards upwards and I will close it like this. So it is forming an anti-clockwise. This is anti-clockwise, so it's anti-clockwise forming. So we know that the current is anti-clockwise and the direction of current is in upside. Simply, if the current flows through the conductor in anti-clockwise, it will form a northwise. It will form north pole, and if the current flows clockwise, it will form south. That is known as clock rule. Simply, then what is electromagnet? When a current is passed through a solenoid means a wire or coil, and with a metallic conductor with a metallic substance inside it, for example, soft iron, the it will act like a magnet. Simply, it will have nearly all the properties of magnet. It will deflect the magnetic field. It will have attractive property towards the magnetic substances. But the similarity is that its polarity can be changed and the permanent magnet polarity cannot be changed, as in case of this. The next is permanent magnet. This simple permanent magnets uses like steel or soft iron. When we wind towards in steel, we wind it and pass the current to it. Pass the current to it, so it will get magnetized for a longer period of time. The next is force on a current carrying conductor magnetic field. We know that if a current carrying conductor or a charge, let's assume a charge moving in a magnetic field, it will experience a force. It will experience a force other than a direction of the magnetic field. It experiences force, and that force is known as Lorentz force. And we can determine the direction of this force using left hand rule. So this depicts the force, current, this one current direction, and this one magnetic field direction of magnetic field. And the magnitude of this force can be identified using formula F is equal to IBL. I is the current base the magnetic field and L is the length of the conductor. So simply IBL. The unit of magnetic field is Tesla. Tesla Weber per meter square. Weber per meter square or Newton per ampere meter square by the formula B is equal to F by L into I. Simply. Now next is electromagnetic induction. What is electromagnetic induction? When we pass a magnet, assume that we have a solenoid and the current is flowing through it, so it will be in its normal direction, means at stationary. But if we bring a magnet towards it, means we have a solenoid, current is not passing through it, a galvanometer attached to it. If we bring a magnet with north pole this side, south pole this side towards it, so it will show a deflection towards that. Means if the assume that this is magnet and this is galvanometer, if we bring it together, it will go towards it. But if we take it back, it will go